Yeah, we will introduce the introduction. It's chapter one, introduction, 1.1 overview. The NVMe Express (NVMe) interface allows a host software to communicate with a non-volatile memory subsystem. This interface is optimized for all storage solutions attached to using a variety of transport, including the PCI Express, Ethernet, InfiniBand, and a fiber channel. The mapping of the extension, the mapping of extensions defined in this document to a specific NVMe transport are defined in NVMe transport binding specification. The NVMe transport binding specification for 5-channel is defined in INCITS 556 5-channel non-volatile memory express 2 FC NVMe 2. For an overview of changes from the revision 1.4 to revision 2.0, refer to the NVMe Express org changes for a document that describe new features, including mandatory requirement for a controller to comply with the revision 2.0. 1.1.1 NVMe Express specification family. Figure 1 shows the relationship of the NVMe Express specifications to each other within the NVMe family of specifications. Figure 1 is NVMe family of the specification. The NVMe Express specification family structure shown in Figure 1 is intended to show the applicability of the NVMe Express specification to each other, not a hierarchical product stack or a system architecture. The NVMe Express base NVMe base specification, that is, this specification pro- defines a protocol for host software to communicate with a non-volatile memory subsystems over a variety of memory-based transports and message-based transports. The NVMe Express Management Interface (NVMe MI) specification defines the optional management interface for all NVMe Express subsystems. NVMe Express I/O command set specification defines data structure, features, log pages, commands, and status values that extend the NVMe Express base specification. NVMe Express transport specifications define the binding of the NVMe protocol, including controller properties to a specific transport. 1.2 Scope. This specification defines a set of properties and commands that comprise the interface required for communication with a controller and an NVMe subsystem. These properties are to be implemented by an instance of a controller using a specific NVMe transport. This specification also defines a common aspect of the NVMe I/O command set that may be supported by a controller. There are three types of controller with different capabilities. Refer to section 3.1.2. A. I/O controller. B. Discovery controllers. And C. Administrative controllers. In this document, the generic term controller is often used instead of enumerating specific controller types. When applicable, controller types may be determined from the context. 1.3 Outside of scope, the property interface and command set are specified apart from any usage from the NVMe, but rather only specify the communication interface to the NVMe subsystem. Thus, this specification does not specify whether the non-volatile memory system is used as a solid-state drive, a main memory, a cache memory, a backup memory, a redundant memory, and etc. Specific usage models are outside the scope, optional, and not listed. analysis. This specification defines the requirement and behaviors that are implementation agnostic. The implementation of these requirements and behaviors are sorry, the behaviors are outside the scope of this specification. For example, an NVMe subsystem that follows this specification may be implemented by an SSD that attaches directly to the fabric, a device that translates between the fabric and a PCIe NVMe SSD, or software running on a general purpose server. This interface is specified above any non-volatile memory management, like wearing leveling. Erases and other management tasks for an NVMe technology like NAND are abstracted. This specification does not contain any information on caching algorithms or techniques. The implementation or use of the other published specification refer to an indexed specification, even if required for compliance with the specification are outside the scope of this specification. For example, PCI Express, and PCI-X. This includes published specification for a fabric and other technologies referred to by this document or any NVMe transport binding specification. 1.4 Conventions. 1.41 was keywords. Several keywords are used to differentiate between different levels of requirement. 1.4.1.1 Mandatory. A keyword indicating items to be implemented as defined by the specification. 1.4.1.2 May. A keyword that indicates flexibility of choice with no implied preference. 1.4.1.3 Obsolete. A keyword indicating a functionality that was defined in previous version of the NVMe Express specification and that has been removed from the specification. 1.4.1.4 Optional. A keyword that describes the features that are not required by the specification. However, if any optional feature defined by the specification is implemented, the feature shall be implemented in this way defined by the specification. 1.4.1.4 R is used as an abbreviation of reserved for when the figure or table does not provide sufficient space for the full word reserved. 1.4.1.6 Reserved. A keyword referring to a bit or byte or word, field, and opcode values that are set aside for future standardization. Their use and interpretation may be specified by future extension to this or other specification as a reserved bit, byte, word, field, property, or register shall be cleared to zero or in accordance with the future extension to this specification. The recipient of a command or register write is now required to check reserved bit, byte, word, or field. Receipt or reserved coded values in defined field in command shall be reported as an error, as writing a reserved coded values into a controller property field produces the undefined result. 1.4.1.7 Shall. A keyword indicating a mandatory requirement designer required to implement or such mandatory requirement to ensure interoperability with other products that conform to this specification. 1.4.1.8 Should. A keyword indicating flexibility of choice with a strongly preferred alternative, equivalent to the phrase "it is recommended." And 1.4.2 Numerical description. A zero-based value is a numbering scheme in which the number 0h represents the value of one hexadecimal represent 2h, 2h represents 3h, and etc. In this numbering scheme, there is no method to represent the value of 0h. The values in this specification are one-based. That is, the number of 1h represent a value of 1h, 2h represent 2h, and etc., unless otherwise specified. Size values are shown in binary units or decimal unit. The symbols used to represent these values are as shown in figure 2. Figure 2 is a decimal and binary units, and the this operator is used to uh, the operator caret is used to denote the power to which that a number, symbol, or expression is to be raised. Some parameters are defined as an ASCII string. ASCII strings shall contain only a code values to 0h through to through 7EH. For the string copyright, the character C is the first byte, and the character O is second byte, and etc. The string is the last justified and shall be padded with the spaces, ASCII characters to 0H to the right if necessary. A hexadecimal ASCII string is an ASCII string that uses a subset of the code values 0 to 9 and A to F uppercase and A to F lowercase. Hexadecimal, that is base 16, its numbers are written in a lowercase h suffix and etc. For example, 0FH and 80H. Hexadecimal numbers are larger than 8 digits are represented with the underscore character dividing each group of 8 digits. For example, 1E underscore DEADBEEF. Binary, that is base 2 numbers are written in a lowercase b suffix. For example, 1001b, 1 or 10b. Binary numbers larger than 4 digits are written in an underscore character dividing each group of 4 digits. For example, 1000 underscore 0101 underscore 001b, or other numbers are decimal, that is base 0, and decimal numbers is represented in the specification by a sequence of digits consisting of only the Western Arabic numbers 0 to 9, not immediately followed by a lowercase b or a lowercase h. For example, 175. This specification uses the following convention for representing decimal numbers. A. The decimal separate, that is, the separating an integer and fractional portion of the number as a period. B. The thousand separator, that is, separating groups of the 3 decimal digits in a portion of the number as a comma. And C. The thousand separator is used in only the integer portion of a number and not a fractional portion of a number. And D. The decimal representation for a year does not include a comma. For example, 2019 instead of a 2, 019. Next is the 1.4.3 byte word and the word relationships. Figure 3 illustrates the relationship between the byte word and the word. A keyword, a quadruple word, as a unit of data that is 4 times size of the D word, size of a word. It's not illustrated due to the space constraint unless otherwise specified. The specification defined the data in a little endian format. For figure 3, byte word and D-word relationships. And 1.5 definitions. 1.5.1 is admin queue. The admin queue is submission queue and a completion queue with an identifier 0. The admin submission queue and a corresponding admin completion queue are used to submit administrative commands and receive completion for those administrative commands respectively. The admin submission queue is uniquely associated with the admin completion queue. 1.4.1.5.2 Administrative Controller. A controller that exposes the capabilities that allow the host to manage an NVMe subsystem. An administrative controller does not implement I/O queues, provide access to data or metadata associated with the user data on a non-volatile memory storage medium, or support namespaces attached to the administrative controller. That is, there are never any active NSIDs. 1.4, 1.5, 1.5.3 Arbitration burst. The maximum number of commands that may be fetched by an arbitration mechanism at one time from a submission queue. 1.5.4 Arbitration mechanism. The method used to determine which submission queue is selected next to fetch command for execution by controller, referred to section 3.1.4. 3.4.4. 1.5.5 Association. An exclusive communication relationship between a particular controller and a particular host that encompasses the admin queue and all I/O queues of that controller. 1.5.6 The process of accessing media to determine correct operation of a sanitized operation, referred to as section 8.2122 ISO/IEC 27040. 1.5.7 Authentication command, used to refer to fabric authentication send or a authentication receive command. 1.5.8 Cache, a data storage area used by the NVMe subsystem that is not accessible to a host and that may contain a subset of user data stored in non-volatile media or may contain user data is not committed to a non-volatile media. 1.5.9 Candidate command. A candidate command is a submit command which has been transferred into a controller and the controller deems ready for processing. 1.5.10 Capsule. An NVMe unit of information exchange used in NVMe over Fabric. A capsule contains a command or a response or may optionally contain command response data and SGRs. Is 1.5.11 Channel. A channel represents a communication path between the controller or one or more media units in an NVMe subsystem. 1.5.12 is command completion. A command is completed when the controller has completed processing the command, has updated status information in the completion queue entry, and has posted completion queue entry to the associated completion queue. 1.5.13 Command submission. For memory-based transport model, and for example PCIe implementations, a command is submitted when a submission queue tell doorbell write has completed that moves the submission queue tail pointer value past the submission queue slot in which the command was placed. For message-based transport model, for example, NVMe over Fabric implementation, a command is submitted when a host adds a capture to a submission queue. 1.4.14 Controller. A controller is the interface between a host and NVMe subsystem. There are three types of controllers. A is I/O controllers, B is discovery controllers, and C administrative controllers. A controller executes a command submitted by a host on a submission queue and a host completion on a completion queue. All controllers implement an admin submission queue and one admin completion queue. Depending on the controller type, a controller may also implement one or more IO submission queues and IO completion queues. When PCI Express is used as the transport, then a controller is a PCI Express function. 1.5.15 directive, a method of information exchange between a host and either an NVMe subsystem or a controller. Information may be transmitted using the directive send and directive receive command. A subset of a IO command may include a directive type field and directive specification field to communicate more information that is specific to the associative IO command. Refer to section 8.7. 1.5.16 Discovery Controller. A controller that exposes capabilities that allow a host to retrieve a discovery log page. A discovery controller does not implement IO queues or provide access to a non-volatile memory storage medium. Refer to section 3.1.2.3. 1.5.17 Discovery Service. An NVM subsystem that supports Discovery Controller only. A Discovery Service shall not support a controller that exposes namespaces. 1.5.18 Dynamic Controller. The controller is allocated on demand with no state. For example, feature settings reserved from a prior associations. 1.5.19 Domain. A domain is smallest individual unit that are shared state, for example, power state, capacity information. 1.5.20 Emulated Controller. An NVMe Express controller that is defined software and an emulated controller may or may not have an underlying physical NVMe controller. For example, physical PCIe function. 1.5.21 Endurance Group. A portion of NVMe in the NVMe subsystem whose endurance is managed as a group. Refer to section 3.2.3. 1.5.22 Fabric Network Fabric. A fabric topology in which nodes passes data to each other. 1.5.23 Firmware boot partition image update command sequence. The sequence of one or more firmware image download commands that download a firmware image or a boot partition image followed by a firmware commit command that commits the downloaded image to a firmware slot or a boot partition. 1.5.24 Firmware slot. A firmware slot is a location in a domain used to store a firmware image. The domain stores from 1 to 7 firmware images. Controllers in the same domain share the same firmware slot. 1.5.25 Host. An entity that interfaces to an NVMe subsystem through a one or more controller and submits command to a submission queues and retrieves command completion from completion queues. 1.5.26 Host accessible memory. The memory that a host is able to access. For example, host memory, controller memory buffer (CMB), or persistence memory region (PMR). The 1.5.27 host memory. The memory may be read or written by both host and controller, and that is exposed to a by controller. For example, that is controller memory buffer or persistence memory region. Host memory may be implemented inside or outside a host. For example, a memory region exposed by a device that is neither a host nor a controller. 1.528 Identify controller data structures. All controllers data structures that are able to retrieved via identify command. Identify controller data structure that is a CNS01H, and each of the IO command and a set specific identify controller data structure that is a CNS07H, and 1.5.29 Identify namespace data structures. All namespace data structures that are able to retrieve via the identify command. Identify namespace data structure that is CNS00H. IO command set an independent identify namespace data structure that is a CNS0H, and each of the IO command set a specific identify namespace data structure that is 05H is 1.5.30 IO command. On IO command is a command submitted to IO command submission queue. 1.5.31 IO completion queue. On IO completion queue is a completion queue that is used to indicate command completion and is associated with one or more IO submission queues. 1.5.32 IO controller. A controller that implements IO queues and is intended to be used to access a non-volatile memory storage medium. 1.5.33 IO submission queue. An IO submission queue is a submission queue that is used to submission IO command for execution by the controller. For example, the read write for the NVMe command set. 1.5.34 Media unit. A media unit represents a component of underlying media in an NVMe command. Endurance groups are composed of NVMe units. 1.5.35 Metadata. A metadata is a contextual information related to formatted user data, for example, a particular LBA of a data. The host may include metadata to be stored in the NVMe subsystem if storage space is provided by the controller. Refer to the applicable IO command set specific for details. 1.5.39 Namespace. A formatted quality of a non-volatile memory may be directly accessed by a host. 1.5.37 Namespace ID NSID. An, an identifier used by controller to provide access to a namespace or the name of a field in SQE that contains the namespace identifier. Refer to Figure 987. Refer to Section 3.2.1 for the definition of valid NSID, invalid NSID, active NSID, and inactive NSID, unallocated NSID, and unallocated NSID. 1.5.39 NVM. NVM is the acronym for non-volatile memory. 1.5.39 NVM set, a portion of NVM from an endurance group referred to section 3.2.2. The 1.4.1.5.40 NVM subsystem. An NVM subsystem includes one or more domains or more controllers and zero or more namespaces and one or more ports. An NVM subsystem may include a non-volatile memory storage medium and an interface between the controller, that is the NVM subsystem, and non-volatile memory storage medium. 1.4.41 The NVM subsystem port. An NVM over Fabric protocol interface between an NVM subsystem and a Fabric. An NVM subsystem port is a collection of one or more physical Fabric interfaces that together act as a single interface. 1.4.42 NVMe over Fabrics. An implementation of NVMe Express interface that compiles to either the message only or the message memory-based implementation of the memory-based transport model definition. Refer to Figure 4 and Section 2.2. The 1.5.43 is NVMe Transport. A protocol layer provides reliable delivery of data, commands, and responses between a host and NVMe subsystem. That is, transport layer is layered on top of the fabric and is independent of the fabric physical interconnect and the low-level fabric protocol layers. 1.5.44 NVMe Transport Binding Specification. A specification of reliable delivery of data, commands, and responses between a host and an NVMe subsystem for an NVMe transport. The binding may exclude or restriction functionality based on the NVMe transport capabilities. 1.5.45 is a physical fabric interface, physical port, a physical connection between NVMe subsystem and fabric. 1.4.49 port ID, an identifier that is associated with the NVMe subsystem port, referred to section 2.2.2. 1.4.49.7, 1.5.49, 1.5.47 primary controller. NVMe Express controller that supports visualization management command on the NVMe subsystem may contain a multiple primary controller. A secondary controller is an NVMe subsystem depend on a primary controller for dynamic resource management, referred to section 8.26. On a PCI Express SRIOV physical function that support NVMe Express interface and the virtualization enhancement capability is an example of a primary controller, referred to section 8.26.4. The 1.5.28 of 48 private namespace, a namespace that is only able to attach to one controller at a time, referred to namespace multipath I/O and naming namespace sharing capabilities, and an MIC field in Figure 280. 1.5.49 property, the generation of a memory mapped controller register defined for NVMe over PCIe. Properties are used to configure to lower controller attribute and obtain a lower level controller status. 1.5.550 rotational media, media that stores on rotating platters, referred to section 88.20. 1.5.51 runtime D3 power removed. In the runtime D3 RTD3, main power is removed from the controller. Auxiliary power may or may not be provided. For PCI Express, RTD3 3 is the 3-code power state, referred to section 8.15.4. 1.5.52 Xenotype operation, process by which all user in an NVMe subsystem is altered, such as the recovery the previous user data from any cache or non-volatile media, is not possible. 1.5.53 Secondary controller, an NVMe Express controller that depends on a primary controller and an NVMe subsystem for management of some controller resources, referred to section 8.26. PCI Express SRIO with virtual function that support NVMe Express interfaces and receive resources from a primary controller is an example of a secondary controller, referred to section 80.26.4, 1.5.45, 1.5.54 shared namespace, a namespace that be attached to or more controller and an NVMe subsystem concurrently. I refer to the namespace multipath I/O and the namespace sharing capabilities (NMIC) field in Figure 280. 1.5.55 Spin down, the process changing the spindle from the operational power state to a non-operational power state for an individual group data stores data as rotational media. Refer to section 8.20. 1.5.56 spin up. The process of changing the spindle from a non-operational power state to an operational power state for any Frangel group associated with a rotational media. Refer to section 8.20. 105.57 set controller. The controller is pre-existing with a specific controller ID and each state and for example feature setting is preserved by prior associations. 105.58 user data. Data stored in a namespace that is composed of the data that the host may store and later retrieve, including metadata if supported. And next, 1.1.6 IO command set specific definitions used in an NVMe-based specification. The following terms used in specification are defined in each IO command set specification. The 1.6.1 endurance group host read command. An IO command set specification command that results to the controller reading user data but may not return the data to the host. 1.6.2 1.6.2 format index, a value used to index into IO command set specific format table that is the user data format number. 1.6.3 Smart data unit read command. An IO command set specific command that results in the controller reading user data but may or may not return the data to the host. 1.6.4 Smart host read command. An IO command sets specific command that results to the controller reading user data, but may not return the data to the host. 1.6.5 User data format. An IO command sets specific format that describes the layout of the data and the NVMe media. 1.6.6 User data out command. An IO command sets specific command that results in the controller writing the data, but may or may not transfer user data from the host to the controller. 1.7 The NVMe command set specific define used in this specification. The following term used in the specification is defined in the NVMe command set specification. These terms are used throughout the document as an example for a specific IO command set. 1.7.1 Logical block. The smallest addressable data unit for the read or write command. 1.7.2 A logical block address LBA. The address of a logical block referred to commonly as the LBA. 1.8 Reference. INCITS 5.502 2019 Information Technology SCSI is primarily commodified as specified available from the 1420 for 514 and 2014 is called the block command 3 SP3 available from, and 529 is 28 Information Technology ATA and ATPI command set ACS4 available from, and 556 and 2020 Information Technology Non-Volatile Memory Express 2 FC NVMe2 available from ISO 8601 is that image and interchange format information interchange representation of dates and times available from as ISO.org. And ISO and IEC is the 17040 as 2015 Information Technology Security Techniques Storage Security available from as JEDEC and JEDEC, the JSDE 218B01, a solid-state drive SSD requirement and enhanced test method standard available from an NVMe Manage Interface Specification, NVMe Command Set Specification, NVMe Joint Names Command Specification, a Key Value Command Set Specification, and NVMe over PCIe Transport Specification available, and the NVMe Express RDMA Transport over Specification, and TCP Transport Specification, PCI Local Bus Specification, PCI Express Based Specification revision 4.0, and PCI Bus Power Management Interface Specification revision 1.2, and PCI Single Root I/O Virtualization or Sharing Specification, and with PCI Firmware Specification revision 3.2, and PCI Code and ID Assignment Specification as 1.11, and RFC 1952 GZIP 5OS specification version 4.3, and RFC 1994 PPP Challenge Handshake Authentication Protocol, RFC 2104 HMAC Q the hashing for manage message authentication, RFC 2631 is a Diffie-Hellman key agreement method, 3629 is Alice technology, and the UTF untransformation format of iOS 10646, and 3986 T Berners-Lee, a uniform resource identifier URI generic syntax 4086 as a randomness requirement for security. 4122, a universal unique identifier UUID URN namespace. 4301 is a security architecture for the international protocol, internet protocol. 4648, the base 16, base 32, and base 30, 64 and data encoding. 62 and the 34 is US secure hash algorithm, is SHA and SHA based HMAC and HKDF, and it's 72 60 96 is Internet Key Exchange Protocol version KIE version 2 V2. The 1979 and 19 is negotiated finite field Diffie-Hellman Affiner parameters for transport layer security (TLS). 84 and 46 the transport layer security TLS protocol version 1.3, UEFI specification version 2.7 and 7, advanced configuration and power interface ACPI specification, TCG storage architecture core, a specification of version 2.0 and revision 1.0, TCG storage interface interaction specification SISR, and 1.9 is a reference under development. INSIT 506.201 SCI block command for SBC available from. Thank you. See you in the next chapter.